Hi guys, welcome to the third lesson for the Embergen introduction course from Proteus JangaFX School. Today we have to focus on the next step about our introduction to emitters and understanding how we can control the emission of fluids and particles. So last time we talked about the shaping. It was useful to understand how to play with the software, how to make stuff, and how to control the emission. By the way, we have to start focusing on the forces, and then we have to move to the emitter properties to understand how to create some more complex setup. And it will be useful to start playing with Embergen to create real world setup to play, for example, with clouds and explosion and stuff like that. So first step is to see the forces. Forces are connected to the force. And in this case, we have a force noise, but obviously we have more forces available. So you see the output of the force is connected to the input force over the emitter. We have the forces for the simulation too, but in this case, we have the force that is controlling how the emission is working with the emitter. And the other way, we have a different simulation. So you see that now the emission is regular. We have no noise. The fluids is emitted in equal way over the entire surface, and then we see turbulence, but that's the turbulence of the simulation, so it's not noise. Okay, so you see everything is really regular and we have no variation. If we go to connect the force, you see that we have variation over the emission. So some areas are emitting, some areas are not emitting. We have different forces. We have the vector field, and we'll take care about it in the future. We'll see how we can prepare it and how we can use it. And then we have three other forces. We are talking about this version of Embergen, obviously. We have the point force, the line force, and the noise. So obviously we can use more than one force over the emission. So we'll take care about it in upcoming exercises. So you know, when we have the force inside the emitter, we are able to control the how the fluid is emitted by the object, and how the dynamic and the velocity will be controlled at the beginning. So inside, let's see something about the force. We have the label. So with the label, we can change the name. We can have the activity, so we can activate or deactivate the force without disconnecting. We have the possibility to change the position. Changing the position, obviously, with a translation over the position or rotation, will change how the force will interact. Scale is scaling the noise. So you see, if the scaling is really high, we have some really big variation over the emission. If we go with a really low scale, you see that we have some small variation. Let's try to have an higher resolution, so it will be more simple. We go for our scale for the voxel sides, and then we go back to the default scaling for our voxel grid. So minus 12 and 12 over the Z, and then apply. Okay, we have to move, and you see that we have a lot of details about the emission with the noise. If we go back to an higher scale, okay, you see that we have this kind of big variation of the movement, the dynamic of the emission, and that's really interesting because it's able to give us the possibility to simulate something like, you know, oil, fire, or maybe some combustion explosion. So something really, really nice and really useful, as you can see. So you see that we done nothing. We changed just essentially the resolution and something about the noise force, and we have a really great result. Seed the seed is able to create variation for the noise. So for example, if we have two forces with the same values for all parameters, but we go to change just the seed, we'll have two different noises. So same scaling, same speed, same gain, etc., etc., but we'll have different animation. And that's really interesting because you can have different simulation just changing the seed. We have the octaves. Octaves give us the possibility to add details to the noise. So we'll have more and more details if we have higher octaves. We can try to have an higher value to see. We should see more turbulence, some more details over the turbulence. It's not so simple to see how it is varying actually, but we can, for example, make a little drawing there, a sketch, just to understand how it is working. So for example, if we pick the color, let's think about like as noise with 1 octave. So it's essentially a color variation with a curve, nothing special, something really simple. Let's say that this one is octave 1, and then we have octave 4. With octave 4, we'll have more details in the same curve. So let's imagine something like that. I'm using spikes, but it is not precise because we can have also more curvy style or more spiky style, so it depends. By the way, we can have the same curve with more variation in the middle, okay? So that's how it works, that's how it looks. So it's nice to have the possibility to have higher details with octaves. By the way, during the simulation it's not so simple actually to see the variation, but you know that you have more complex simulation. We have the linearity and the gain, so we have the possibility to control the frequency and the amplitude of the for each octave. So we have some possibility to control more in detail how it is looking. It's not so simple to see how it looks, maybe just because now we have an explosion with smoke and stuff like that. So we will use it, for example, to create the cloud simulation. By the way, let's go to the other value. We have the amplitude. Amplitude obviously is the amount. So you see that in this way we have a really big explosion style. So it is something like really interesting because it is creating a big explosion just because we have big variation for the mission, and that's a simple way to achieve a really nice looking result. Again, it seems like an oil explosion, because we have this step-by-step variation on the mission. So we have a large scale fire, and then we have smoke, and then again it seems that we have less fire, and then we have again a really large scale fire emission. So that's really nice. Obviously we are not controlling the bursting, it's something different, but it's a simple way to achieve something like that. So the bias gives us the possibility to essentially move the noise in a direction. So you see that, for example, now we are giving the bias over the x positive value. So you see that the noise is moving in this direction. So it's something like a wind force, So it is something similar to a wind applied with a force. So that's another really interesting thing, because we have the possibility to have more forces together in the same one. Then we have the animation speed. The noise is animated, so that's essentially the speed of the noise variation. So you can have a faster variation having a higher animation speed, or you can have a slower variation with a low animation speed. So that's essentially really simple. You have just to make tests and play with it, because Embergen is completely real time, so it's simple to understand how this value can work and how he can control your animation look and your dynamic. So let's go back to some values more similar to the default value we had at the beginning. So in this way we can play more with the simulation. So we can, for example, move to the emitter to understand how the emission works. We are not going to talk deeply about every single feature, because you know, I like just to show you how the emitter works, how the emission works, and then we'll start playing with real world cases and task solution to play with the other feature of Embergen. So let's pick the emitter. You know, here we have a lot of parameters. We have, you know, you can, for example, close and open the tabs just clicking over the tab name, because, you know, we are starting to have a lot of value, a lot of parameters, so maybe it's more simple for you to play also with the scaling. I'm going to play also with animation, so that's why I'm giving a little bit of space over for the bottom. By the way, you know, we have the possibility to activate the advanced interface. Advanced interface will give us different parameters for some tabs, just to be able to play more in depth with some feature. You know that we have, for example, smoke and temperature and fuel, and here you see that we have just emission, so we have a deeper control. Let's go back to a lower scale so we can be faster to simulate when we go to make parameter variation. So back to our scaling for the bounds, and then we are back. We are just to see, okay, we are here, so I just moved the emitter, it's not a problem. You know, just it is just to see how it is looking, so nice. Okay, perfect. We have the right preview. You know, with this checker we can activate the emission. If we click there, we have three states. The one we are interested in is the possibility to create the animation. So you see, if we click 3 times, we have the possibility to create a key, and here we have a dop sheet essentially. So we have the parameters, we have the current state at the frame you have, and then you have, with the right mouse button click, you have the possibility to create a key. In this case we have just a state, so we can set to on or off. Then we can create a new key here, we can say that it's still on, and then we can create another key and say that that's off. Okay, so essentially we have the emission and then it is stopping. Really simple and effective. You know, we can move the key over the dop sheet, it's not a problem. So back, we play again, and we have this kind of simulation. And obviously we'll take care about the animation more in depth. It was just to show you that it works perfectly. Let's go back to have the no key, so we are not anymore using the key. We have just to set again to on. Okay, so we have the same setup we had before. You see that there we have the burst duration, because we have a burst to use the fuel to emit the fluid and the fire. So if you change the duration of burst, maybe you can see some small variation, but essentially it is linked to the time between bursts, because in this way we can control how many bursts we have. So if we have this one and then we go to play with a time between bursts, we'll be able to have some really nice effects. So let's say, for example, that here we have a time between the bursts, so let's say 1 second. So you see that we have a burst. So the fuel is burning, and then it is setting to off, and then again we have the burning. So in this way, for example, we can have a longer burning, and then we have a pause, and then again we have the burning. So in this way you can control, for example, some kind of nice explosion, because we have this kind of cycle between the burning. So it is not burning every time. We have some kind of cycle that is controlling how the fuel is burning and creating fire and smoke. Then we have the position. Here we have, as always, the translation and rotation for the emitter. And then some simple parameters are useful to control the emission. We have the fuel rate and smoke rate and the temperature. So that's the simple way to control the emission. We can say that we have more, for example, more fuel or less. If we set to 0, we have just smoke and we have no more fire. If we have a really high value, like 150% by seconds, we have more fire. And then if we go back to a lower value, you see that we have again just a little bit of fire. So you are controlling how much fuel is present in the simulation and is able to burn. Okay, then the smoke rate is controlling essentially the smoke. So in this way, if we set to 0, we have just fire and we have no smoke. If we go higher, obviously we'll have more smoke and we can have a really high value. You see that we have a really dense and pyroclastic smoke, because we are emitting a lot of smoke for each voxel in the grid. So in this case, obviously the smoke is really high, so we are not so able to see the fire, just maybe a little bit. So we need to have more fuel, obviously, to have the same effects we had before. So you have to take care about both to understand, to control the final result about the emission. Then another interesting parameter is essentially the temperature. Temperature is controlling the temperature maximum inside the voxel bounds for each voxel grid, obviously. If we go lower with the temperature, we have no fire because we are not able to have the burning. But you know, we have something else. We have also the smoke that is rising really slowly, or no rising up. That's because the temperature is controlling with the buoyancy the possibility that the smoke is rising up, moving up. So we need a higher temperature to move up the simulation. So you see that if we start to have a higher temperature, we have no fire because it's not able to make the fuel burning, but we start to see the smoke rising up. And again, obviously, if we have a higher value of temperature, we'll be able to make the fuel burning. So you see, for example, now we start to have a little bit of burning. Obviously, if we go up, we'll have more fire. And if we go really up, we have a longer time for the burning. So you see that we have fire rising up because the temperature is higher. And we have obviously a brighter color because the color actually is controlled by the temperature too. So that's why we see something like that. So really simple and effective. So guys, I think that you are able to understand that using Embergen is really simple. We are still working with a really simple setup. We are just starting to scratch the basic knowledge about the software, and obviously we are going step by step to do something more complex. By the way, also there you can control by animation, controlling the value. In this case, obviously it's not a checker, but we can have a higher fuel rate at the beginning and then less. So in this case we have fire at the beginning because we have the burning, and then we have just smoke. Okay, so as you can see, the animation works always in the same way as we done before, and that's just simple animation. Okay, We can mix some animation for different parameters to control, for example, explosion and really some nice effects about the dynamic of the fluid. So I think we can stop and continue in the next part to talk about the emission, but in the next part we are going to talk about the emission and some information about the simulation, playing directly with the first setup. We're going to create a cloud, and step by step we'll move to a cloudscape, so we will try to control more clouds all together, and then we'll move to more topics like explosion, fire, smoke, and stuff like that. So it's time to start playing in a really nice way with Embergen to create some amazing effects. And I can say just thanks guys for watching, and we'll see more Embergen stuff really soon. Bye bye.